Okay, well, it's 1 o'clock, so let's go ahead and get started. Any questions?
No.
I guess it's just me and you so far today, so. All right, now there's some more. All right, so today we're going to talk about section 4.4, which is graphs of logarithmic functions. So it's kind of like an exponential, we're going to learn how to graph the base function, and then we're going to learn, all the different transformations, up and down, left and right, reflect across the axes, things like that. So that's what the whole thing about today is. So what about the domain of a logarithmic function? Well, if you remember back when we did exponential functions, that's defined by the y equals b to the x. So for any real number x and a constant b greater than 0, but not equal to 1, because then we're not going to have anything happening, then the domain of y is from negative infinity to infinity, and our range is from 0 to infinity. Well, then in the last section, we learned that the logarithmic function y equals b base b of x, it's the inverse of the exponential function. So because they're inverses, what was the range is now the domain, and what was the domain is now the range. And so what we see is now those things have been flipped. And so the domain is now 0, infinity, and our range is from negative infinity to infinity. All right, so how do we determine what the domain is? Well, we do it by basically setting up an inequality. And what we're going to do is we're going to look at what's inside of here. So, this one only has x, but sometimes you might have 3x plus 4 or 5 minus 2x or something like that. And we put what's inside of there and set it greater than 0. And then we solve for x, and then from there we know the x is going to be greater than such and such, and so that's going to be our new domain. And so what we're going to do is we do a couple examples of these. And so in this case, again, all we're looking for is the domain and range. Well, guess what? The range on all of these is going to be from negative infinity to infinity. So all we really have to do is we have to find the domain in each case. And so what is the domain? Well, again, what we're doing, we're setting what's inside of here greater than 0, solving, so we add 2 to both sides, and so x is going to be greater than 2. Well, now we write the domain based on this, so the domain is going to be basically from 2 to positive infinity. Okay, so it's going to be everything going to the right. And if we think about this, usually what we have is for a lot of these, the asymptote is the x equals 0. And then we're going to find out eventually that when we have this minus 2, we're going to shift to the right. And so instead of having the minus or 0, it's going to be over here at x equals 2 is our asymptote. And so it's not going to ever touch that. And so that's why it's going to be from 2 to positive infinity. Now this one here, well, that's going to be pretty easy, just like the last one, x minus 5 greater than 0. So x is greater than, that's a 5, not a 0. Let me erase that here. All right, so it's going to be greater than 5. So then our domain then is just from 5 on up to positive infinity. Now, not always are they going to be, from a number up. Sometimes we have something like this. And so what we do is we, again, set that greater than 0 and solve for x. Well, I'm going to go ahead and take that 3x to the other side. And so that gives me 12 is greater than 3x. So I divide by 3. And so then it says 4 is greater than x. Or if you read it from left to right, with starting with x, x is less than 4. Well, if x is less than 4, that means it's going to go from negative infinity up to that 4. And then it's going to be a parenthesis there. So it's going to be going everything that direction there. So that's how we find the domain and range. And again, the range is just our negative infinity to the positive infinity, and that's all we have to worry about. Now, let's look at some characteristics of our function. Now, the base function is basically log base b of x. So that's going to be our base. And b can be anything. It can be 2, e, log base e is going to be ln, but we can also put just the e there. We can have base 10, and that's just going to be log of x. So there's all going to look at the similar way here. So basically, we're going to have any real number x, and it has to be greater than 0, but can't equal 1. and it's going to be 1 to 1, so we can draw however many horizontal lines, and it's only going to touch once. We have the vertical asymptote, like I said, at x equals 0. Our domain, because at this point here, it's going to go from basically 0 all the way to positive infinity, but it doesn't include the 0, so it's going to be a parentheses 0 infinity. Now our range, we can go all the way down, and we're going to go all the way up, and so it basically covers the whole set of real numbers from negative infinity to positive infinity. Now the nice thing about the log functions, we always have 2 key points. We have the point 1, 0, and so that's always going to be a point on our graph if we're just plotting some log base b of x. And we're going to have some point b1. So whatever our base is, it's going to be that. So in this case, it looks like it's a log base 2, and so then that would be what that is the b is equal to 2, and so be 2 comma 1. Okay. And then, so those are the 2 key points. We also have the vertical asymptote. And so with those 3 things, we can actually draw a picture. So we'll have the 2 points, we have the asymptote, and so we try to draw a smooth curve, through those points and not touching the asymptote, and then just increasing forever to the right. Now, because of that asymptote, we don't ever have a y-intercept because it gets close, but it doesn't actually touch when it's in this form here. Now, if b is greater than 1, we're going to have this increasing. So it's going to look like that. But if b is between 0 and 1, then we're going to get this decreasing function. And if you think about it, if we have our b is, say, 1/2, then that's going to be 1/2, 1. And so that's that point. And so that's why it's decreasing, because we've kind of swapped how it looks, and it's going to be on the decreasing smooth curve. Instead of, if it was 2, then we go over 2 and up 1. So we kind of have to think about how the curves are going to look based on, b greater than the 1 or b between 0 and 1. So decreasing between 0 and 1 and increasing greater than 1. Okay. Now we can also have compression. So depending on what our base is. Now if we look down here, we have the red, the blue, and the orange line. Well, the highest one is going to be the one with the smallest base. So in this case, 2. Now, if we had a half, it would even, be different than that. But then we have here, that's going to be e, ln, that's going to be log base e of x, which is 2.7, blah, blah, blah. So it's, bigger than 2. And then log of nothing, that means log base 10 of x, and so it's even bigger, and so it's kind of pushing it down. So they're kind of getting compressed with the larger b values that we get here. Okay, and what the reason for that is because as we have the 10, if that's a 10, we have to have 10.1. This e, we have to have 2.7, and so we're going to have like 2.71. And then log base 2, that's going to be 2.1. And so that's going to be right there. And so that's kind of how we're getting those things. It's getting our 2 points, and then we can draw our curve. All right, so again, what we're going to do is they're going to give us some functions, and we actually have to graph them. And so the key thing is we draw and label the vertical asymptote x equals 0. And again, that's in the form like this. We don't have shifts yet. Then we have our x-intercept. Well, that's the 1, 0. Our key point is b1. Well, that's just whatever the base is, comma 1. And then we draw a smooth curve through the points. So again, I'm not a good drawer, but that's beside the point. And so it's as smooth as possible. And then we state the domain. So in the case where this is like this, it's going to be 0 infinity. The range should always be negative infinity to the infinity. And then in this format, the x equals 0 is going to be our asymptote. And again, that's kind of one of our key points, the asymptote. The 2 key points here, the x-intercept and the key point, and those 3 things will get us the curve. So let's go and look at an actual one where we have to plot something. All right, so, well, what do we have? Well, we have the base is equal to 1/5. And so let's start drawing what we know and what we can get on here without doing too much of anything. And maybe I should make the asymptote a different color since it's going to be right on top of this line. So it's going to be like that. That's our asymptote. And so that's going to be x equals 0 is the asymptote. Okay. Now let's start making some marks here. So we have 1, 2, 3, 4. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. All right, so remember, we always have the point 1, 0. So we know that's going to be one of our points. Okay. Now what else do we know? Well, we know the other point is going to be a key point, and that's b comma 1. Well, b in our case is 1/5, so it's going to be 1/5 comma 1. And because this is between 0 and 1, we know it's going to be a decreasing log. So we look for 1/5 1. Well, that's somewhere, in that area there. Who knows how close we are. And so now with those three things, we know it's never going to touch the x equals 0, and it's going to decrease. So it's going to come down and then do something like that. And again, bad drawing, but I can't draw very well, so that's beside the point. So that's going to be kind of how it looks here. So that's just a general shape. And so we know our domain is going from, well, we're never touching 0, so 0 to infinity. Our range is from negative infinity to positive infinity, and then that's our asymptote. Okay, so that's all the things it asks for. And again, it's just general. And the key thing is we just need, the 1/5 1 point, we need the 1 comma 0 point, and we need the asymptote, and we can draw the general shape of the curve. If we wanted to add more, we could, but those are the three things that we need to get the general shape. Now what we're going to do is what we've been doing on everything the whole semester pretty much is we're going to do some horizontal shifts, vertical shifts, stretches and compressions, and reflections. And so again, this is just the overview. We will go through each of them more specifically as we move through. So with horizontal shifts, basically we're going to add some constant c to the input of the parent function. So we're going to put it into the input, which is within the parentheses here. So, if the c is less than 0, it's going to move it to the right. And so we'll have something like x minus c. And if c is greater than 0, we're going to shift it to the left, and it's going to look something like x plus c. So things like we've seen before, when it's positive, you move left. If it's negative, you move right. So that's not a change. Now here, vertical shifts, they're going to be exactly the same. And now what we're going to do is we're going to add it to the parent function. So it's going to be out here. We're going to add something over here. So we're going to have a positive d or a negative d. If it's a positive d greater than 0, it looks like that, and we're going to move up. And if it's a negative d, basically, we're going to move down on the up and down on the y-axis. Now, stretches and compressions. Okay, well, those are going to be multiplied by some constant a. And actually, this should probably be greater than 0, not 1, because I think I had a typo there. I do that a lot. But I think what I do is I copy a lot of the book, and the book has a lot of typos. And so because we're going to have possibilities of a greater than 1, we also have possibilities of a between 0 and 1. So there's going to be two possibilities here. So we should just say greater than 0 here. And so this is going to be our a. I'm just going to multiply it out in front. So that's going to stretch it or compress it depending on what it is. If a is, well, actually, this one's greater than 1. It should be a stretch. And if a is between 0 and 1, then it's going to be a compression. And that's what the compression looks like. This is what the stretch looks like. Okay. And then we have reflections. And so they're pretty much the same as what we've seen. So if we take a negative of the whole parent function, basically, we're going to reflect it across the x-axis. And if we take the negative input, then we're going to reflect across the y-axis. And we'll, again, see all these in play and how they work and how they change the domain. The range stays the same, but our domain will change because of how we're reflecting it across the axes. All right, so the first one that we're going to go into in detail is the horizontal shift. And again, we're just adding a constant c inside of here. So in the input, we're adding c. So what that means is if we have a positive c here, we're going to shift left. If we have a negative c, we're going to shift right. And so that kind of shows what we have here. Shift left if c is greater than 0, and shift right if c is less than 0. Now we're going to have the vertical asymptote of a negative c. Okay, so think about that. If we have our original and our asymptotes here, if we shift left, then we're going to have to move our asymptote over here. And so because this says plus c when we shift left, we're going to have to say the asymptote's now x equals a minus c. Now, if we have a minus c here, that means we're going to shift right. And so then our asymptote all of a sudden becomes over here. And if it's a minus c, we actually need a plus c. And so that's going to be x equals c. And so that's why the vertical asymptote is basically the opposite of whatever c is in our inside our parentheses here. And because of that, our domain is going to shift too, and it's going to go from negative c to positive infinity. So if we shifted left, it's going to go now from a negative c to positive infinity. And if we shifted right, it's going to go from a positive c to positive infinity. Okay, and these are just kind of some graphs on how it works. And the key point is it's a lot easier sometimes to plot our original, because we know we're going to have a 1, 0, and we're going to have a b1. And then if we're shifting left, well, we just have to move our x left that many positions. So in this case, we just take 1, our initial, minus c, we get our new point. And here we start with b, we subtract off c, however many we move there, and we get our new point here. And then our asymptote is just whatever the opposite of c is. And so it comes over here, and then we can draw our graph from there. And so that's kind of one of the key things to do is, have those 2 points, move them, and then you have your new points you can draw your curve through. Same things when we shift to the right. So if we have now why does this say a plus c? This should be a minus c. And I didn't draw this, so this is, oh, actually I see what it's doing. Okay, never mind. I see what it's doing because we're adding c to it. We're not saying that's the function. This function is down here. All right, I overlooked that. So our function now is minus c, so we're moving c units to the right. So, we start here. We have our 1, 0, and b1, and now we're going to move c units to the right. So we're going to take b plus c and 1 plus c. Now our new asymptote is the x equals c, whatever it is here. And so then we can draw our new graph of the function. And so a lot of the exercises that are in the book, they tell you to, draw the parent function first and then draw the secondary function and then write your domain and range. And so that's kind of what I'll do a little bit here. And then one or two of them I'll just kind of plot points and then kind of do like we did before. If we have plus c, we're going to do this to that point, and then we're going to do this. And so we'll kind of do it a couple different ways. All right, so this one, we want to plot the parent function as well as this. Well, what is the parent function? Well, the parent function is just y equals log base 3 of x, because all we've done is we've added this 4. Okay. Now, when we add that 4, what does that mean? Well, that means we're going to move left 4 because we have a plus 4, so we're going to move left 4. So let's go ahead and draw what we know here. So we have 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. All right. So with this one, we know we have the point 1, 0, and then that's our b. So that's going to be 3, 1. So those are our 2 points. Our asymptote is right here for their initial point. And so we have our 1, 0, and then we have our 1, 2, 3, 1. And so this function is going to look something like that. Now we're shifting 4 units to the left. So I'm going to just take and look at my point here. And so, well, first I can get my new asymptote. That's going to be 1, 2, 3, 4. So my new asymptote shifted 4 units to the left is here. So that's going to be x equals minus 4 is the asymptote for the new one. And then I just move my points by 4 too. 1, 2, 3, 4. So that's my new one there. And then I have 1, 2, 3, 4. That's my new one here. And so now my graph, almost hit the point. It looks something like that. Okay. And again, what they want us to label as asymptote, we got that. Our domain now has changed. Now we're going from a negative 4 all the way up to positive infinity. And our range, it's still the same, minus infinity to infinity. Because if you think about it, we can keep going down this way for infinity, and as we keep going this way for infinity that way, it just keeps going up and up and up, and then it'll go to eventually infinity that direction as well. And so our key points are this one, which now is equal to 1, 2, 3, minus 3, 0. This one is minus 1, 1. And then the asymptote, our original one, since they say for both functions probably, this was 1, 0. This was 3, 1. And so now we have all our key points, both graphs of the parent as well as the the one where we moved to the left for, and we have our asymptote old and new, and we have our domain. And the domain I'm just going to write for the new one, because the other domain was just the 0 to infinity. Okay. So that's how we would do something where we shift left or right. And we could have done it to the right as well. If this had been minus 4, we would have just shifted everything to the right 4 and had that. Now, vertical shifts are going to be a little bit different, because what we're going to do is we're just going to add the d to the end over here. And so it's positive if it's going to go up, and it's going to be negative if we go down. That hasn't changed on anything we've done from the whole semester. That one's pretty easy. And so our asymptote doesn't change because we haven't changed anything except for where the graph is up and down. And so our asymptote is still going to be x equals 0, which means our domain doesn't change, which means our range doesn't change. And so all it does is it shifts our up and down. So what I've got here is the ones in the book are not right, so I don't know what they were doing there, or they're a little confusing. And so we have the base b, and so that's going to be 2, 1 is going to be our original point. And we also have the 1, 0. So those are our 2 key points on this place. So that's our 1, 0, and then this is our 2, 1. Now we're moving up by 3, so we just have to move up 3 points. 1, 2, 3, that's our new point here. And we move up 3 here. 1, 2, 3, and we have our new point there. So that's all we do. And the same thing works for when we subtract d. So this one, we just subtract, and then I think it's the same thing, 3 instead of d. So if we say that's 3, then we move down 3, 1, 2, 3, that's our new point, and then 1, 2, 3, and that's our new point there. And then we can draw our curve through that set of 2 points, and making sure we don't go over the asymptote. Okay. So let's look at this one. So let's go ahead and draw our axes. All right, so what is our base function? Well, our base function is y equals log base 3 of x. And so what does that tell us? Well, we have the point 1, 0, and we have the point now 3, 1. So that's our original. And now what we're doing is we're going to move up 2. Okay, so let's go ahead and draw in our stuff. So, we have our axis here. That's going to be our x equals 0 is our asymptote. And then we have our point 1, 0, and we have our point 3, 1. So 3, 1. And so our first graph, across the axis there, that's not right. Can't we erase without, Did I just delete the whole thing? Where did I go? Here we go. All right, so let's maybe start this direction and go down. So that would be our base function here. Now when we move up, we're just going to move up by 2. So we're going to go up 1, 2. Here we go, up 1, 2. And so now that's more what it looks like for the second one. So that's going to be our parent function as well as our transformed function. And our key points, as you can see, this is over 1 up 2, and this was over 3 up 1, and then now we're up to 3. So nothing hard. And again, if you wanted to write your pairs here, what we've done is though the new one is going to be 1, 2, and this one's going to be 3, 3. And so sometimes it's easier just to write the numbers here, and then so this is your original, and this one's up 2. Okay. All right. So the next thing is the vertical stretches. And again, it all depends on what your A value is. So if your A is greater than 1, it's going to be a stretch. And so it's going to move it up. It's going to stretch it up away from the x-axis. And if our A is between 0 and 1, that's going to give us a compression. So it's going to compress it towards the x-axis. So our vertical asymptote, that doesn't change. We still have our x-intercept of 1, 0. We still have our domain. We still have our range. All it does is affects the shape of the curves. And so here we have our original curve, and it's y, or y equals log base 4 of x. And if we have a greater than the 1, so say we have 3, what it's going to do is going to stretch it up. It's going to move it up, and that's all we have to worry about. And so a lot of times the thing to look for is, so we have our 1, 0, then we have our 4, 1. So if we take that 1 times 3, 1, that's 1, 2, 3, that's going to be our new point. Now this one doesn't change, it stays there. And so, you know, if we think about it, our original is 1, 0, and 4, 1. Now we're going to take it times 3, take the y times 3. Well, that still gives us 1, 0, and this is 4, 3. And so that's how it's going to be affecting it. It's going to make it just go up higher, and then we go across over there. Now with compression, what it's doing is we're taking it times a third. And so, you know, if we had the same number, if we take y times 1/3, well, we still get, guess what, 1, 0. But now instead of 4, 3 or 4, 1, what we get is 4, 1/3, because we're taking 1/3 times that 1. And so at 4, we're at this 1/3 point. So that's going to be our new point there, whereas before it was the 4, 1. And so that makes it kind of go up higher here, and then it goes over like this. And so it kind of has a more steep initial point here, and then it kind of curves over like that. Okay. So what do we have here? Well, it wants us to sketch a graph alongside the parent function, include key points again. So if we have our base, which is y equals log base 2 of x, we have our 1, 0, and we have our base is 2, so it's going to be 2, 1. And then what we're going to do is we're going to take 1/2 times our y, basically. And so the new points are 1, 0 still, and here it's going to be 2, 1/2. So let's plot those. Remember, our asymptote doesn't change, our domain doesn't change, our range doesn't change, and so we still have x equals 0 is our asymptote. And so now we just have to go 1, 2, 1, 2. And so we have our point 1, 0 for our original, and then we have 2, 1 for our original. Well, and so if we draw that, I don't know how that's going to look, kind of close points. So well, obviously I didn't hit anything there. And then 1, 0 again, so that's going to be a little bit bigger 1. And then it's going to be 2, 1/2. So it's going to be down here. And so what's going to happen is it's going to come up further here and then cut across like that. Okay. And so that's going to be how we get our graph. Now again, our domain is still 0, infinity. Our range is still negative infinity to infinity, and our asymptote is still x equals 0. So all it did was affect really that second point in how the graph actually looks. Okay. And so I guess including your key points, sometimes it's easier just to kind of make tables like that, and that makes your key points right there. All right, so now we get to add all the things together and kind of do it as a whole. And so what I'm going to do is I'm going to make kind of a table like we've just been doing and go through each of the pieces to kind of see where it goes. So our base function is y equals log, and it's nothing here, so that means log base 10. So I'm going to write that just so we remember of x. Okay. And so our original point is going to be 1, 0. That's always going to be there. And then it's going to be 10, comma 1 for our second point. So this is a start. And then the first thing we're going to do is this. Now minus 2 means we're going to move right 2. So now we're going to say right 2. And so that's going to change our x values. So if we add 2 to 1, that gives us 3. That doesn't change. Now if we add 2 to 10, that's going to give us 12, 1. That part doesn't change. And so now we've taken care of this. Now we will work with this part. So now we're going to take 3 times y, basically. Okay. So what is 3 times y? Well, if we take this number and take 3 times it, well, we still get 3, 0. Now if we take 3 times y here, we're going to get 12, 3. Okay. Then, so that part's done. Now we have the up 1. So we're going to move up 1. Well, if we move up 1, that's still going to be 3 because that's the x, so that doesn't change. But we're going to go up 1 here. And the 12 doesn't change, but we're going to add up 1 here, so that's going to be 4. Okay. Now this one doesn't say sketch the parent graph and all that. All it says is sketch the final one. So this is going to be our points we can put on the graph. Now what is our asymptote? Well, if we want to set that greater than 0, we move it over. So it's going to be 2 is going to be our asymptote. So we'll have to go a ways out there because we have to go to 12. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We'll have to go 1, 2, 3, 4, 5. All right, so our asymptote is at the 2. So, yeah. And now we have the 0.31. So we have 0.31. We have the 0.124. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so I only put that many, so it's going to be about there. And so now we have some graph like that. And again, drawing this freehand is not nice. If you're able to see it on your calculator or on Desmos, you should see how nice it really would be. But the key is we're able to have our original, and then we have our different things that we've done to it. We went right 2, then we went 3 up, or 3 times the y, and then we moved up 1. Okay, and so I could maybe not have you draw graphs because that's going to be hard on the test, but I could have you start with your base function and then tell me what the 2 key points are and what is the asymptote, of the new graph of the new function we have here, the 3 log of x minus 2 plus 1. So that's kind of the things that we could do for testing, actually, is do something like that, have that, and have your x equals 2 as your asymptote. Okay. All right, so the next thing is the reflections. And so when we have the first one, we're taking basically minus times the y. And so when we do that, it's going to reflect across the x-axis. So, if we had initially this, that point doesn't change. But if we had our other points, it looks like it must be 1, 2, 3, 1. Well, if we take a negative of the 1, that comes down here, we get a negative 1, and so we're reflecting. And so then we can take that, it looks like a half, 1.5, and so that comes down to negative 1.5. And so it becomes a decreasing function if it originally was increasing. Now, if it was originally decreasing, then it becomes an increasing function, but it reflects across that x-axis. Now, if we have the input is going to be negative, it changes. So if we initially put in a 1, well, guess what? If we do that, the negative of that is negative 1. If we put in here, it looks like 1, 2, 3, then the opposite that's going to be negative 3, and so this is going to be over here at 1. And so then that reflects it across the y-axis. So this one is going to be one where we actually have to do a little bit of work because we have to reflect across first the y-axis and then after that the x-axis. Now it just says sketch the final graph, so we don't actually have to worry about sketching each individual piece. So what are our points we know? Well, we know it's going to be 1, 0. Well, guess what? That is going to be a 10, so it's going to be a 10, 1. So that's original. Now what are we going to do? Now we're going to change our inputs. So it's going to be negative of the x. And so what does that give us? Well, that gives us a negative 1, 0. And that gives us a negative 10, 0. Oops, that's a 1. I don't know where the 0 came from. Okay. Now what we're going to do is we're going to do the negative out front. So we're going to change the sign of the y. And so now we're going to take the opposite of whatever y was. Well, that's a negative 1, 0. And that's a negative 10, negative 1. Okay. So now let's see what does that actually give us as far as our final value. So we know we're going to be on this side over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we're going to be down here. We don't have to worry too much about those over there. And so negative 1, 0 is going to be 1 point. And negative 10, negative 1 is going to be the other point. And it looks like it's going to be increasing based on how this is going to be. And so it's going to look something, again, drawings leave a lot to be needed here. And so that's going to be what our graph looks like. Now, what is our asymptote? Well, our asymptote hasn't changed. That's still going to be x equals 0 is our asymptote. Now, what is our domain, though? Well, our domain is what x values. Well, we're going from negative infinity all the way up to 0, and so that has changed. What about our range? Well, we're going from negative infinity all the way to positive infinity, so that actually hasn't changed at all. And so we have our domain, we have our range, our asymptote, and if they wanted, we have our two key points, which are these 2 points here, which helped us actually draw the graph. Okay. So again, that's kind of the gist of how we're doing things as far as shifting left, right, up, down, across the axes, things like that. Now the nice thing is we can also use our calculator. And so what happens is sometimes we're going to get some kind of a nasty equation that looks something like that. And they want us to solve it, and the only really way to do that is do it graphically. And so what we're going to do is we are going to plug in one side of the equation, this one say, into y1. Then we're going to plug the other side into y2. And then we're going to make sure when we graph it, the window's correct for the intersection so we can actually see that intersection. And then we're going to use our intersect on the second calc, number 5, to find that intersection. And this time it says that once it rounded to 3 decimal places. So let's go to our calculator to make sure we know how to do that. So we're going to have y, and when we're doing these, obviously we can only do common logs and natural logs. We can't do log, base, anything else because we don't have that functionality in our calculators. So I believe it was 5 log, and then it was x plus 2, and that was the left side. Now the right side was 4 minus, and then it was a log of just x. Okay. So I think those were the two it had. Now let's see. Okay, well, it gives us a window that we can actually see that intersection, so that's good. So now we just have to hit the second trace, which gives us a calculation feature. Now we want a 5. And so let's move over a little bit. And so yeah, that's going to be our first curve is blue, our second curve is red, and I'm just going to hit X for a guess. And so that's going to be our value. It's going to be, and it said to the 1,000, so 3.04, and then it's going to be a 9. So 0.349. So that was X equals, or approximately equals to 3.049, rounded to 3 decimal places. And so that's how we can solve these complicated ones using our calculator. Again, we plug one into y1, we plug the other one into y2, we do the second calc in the intersect feature number 5, and then we just read the number off of the calculator screen for the x value, because that's what we're looking for. What is the x? Okay. So that's one of the nice, easy things that we can do using our calculator. All right. What about this one? What is the vertical asymptote of this? Well, we've been working with log base, 10 or things like that. Well, this one, remember, is really just log base e of the x minus 1. And if we go ahead and put our 3 plus here. And what was our vertical asymptote? Well, what does this tell us? Well, that tells us we're shifting to the right 1. And so if we shift to the right 1, originally our asymptote was x equals 0. So if we shift right 1, our new asymptote is just x equals 1. And so that's our asymptote. And so that's all they really want us to do on this one, is look at this and tell us where is the asymptote. And so in this one, we just moved right 1. So we just know that from 0, we move right 1 is 1. And that was all we have to do. So that was a pretty simple one. All right. The last problem I'm going to do for today is basically solving or finding the equation. And they tell us what kind of log it is. They tell us it's the natural log. Now, they could have said it was a common log, base, whatever, but they said it's the natural log. And so what we have to do is figure out, what does that mean? Okay, well, first, the key things are we have to kind of look at our points. We have to find kind of maybe 2 critical points and also the asymptote. Well, if we look at our picture here, it looks like our asymptote must be right there. And so x equals a -3 is our asymptote. Okay, so that's a key step there. And then what are our points? Well, if we look here, there's not too many that looks like it crosses. That one might be, and maybe that one. And so what are those points? Well, those are -2, -1, and that one's 4, 3. Okay. So those are 2 points and the asymptote. So that is enough to actually have us find out what the equation of this natural log is. And so what we have to think about is, what is our original equation? Well, it's going to be y equals, and we don't know if it's compressed or not, and so we have to have an a value. And then we have the ln, and then we have x. Now remember, we moved to the left 3 because we have that x equals a -3. And so this is going to be a +3 here, because to move to the left, we have to have a plus. And so that's one key thing we know. And then after that, we have, we don't know, has it been moved up or down? We don't know that. And so that is going to be our starting thing. And this here is really what helps us, because we know our asymptote. And now what we have to do is we have to plug in 1 point and solve for one of the variables. We'll have to see what it'll solve it for. Maybe it'll solve for k, maybe it'll solve for a. And then after that, once we solve for one of those, a or k, then we plug in our other one, and hopefully we can solve for the other a or k after that, and then that will give us an equation. Now, again, we're assuming that's a -2, 1, and we're assuming that's a 4, 3. Now, it doesn't look like it's quite 4, 3, but we're going to use it as 4, 3. And so we're going to do some rounding basically when we get done to get our final equation. All right, so if we plug in the -2, -1, y is -1, that's equal to a times the ln. Now x was -2 plus 3, then plus k. Well, what does that give us? Well, it's -1 equals a times the ln of 1, and then plus k. Well, what is the ln of 1? Well, that's equal to 0. And if we want to check that, we can plug that into our calculator. And so we go second mode, and we'll say ln of 1, and we get 0. Okay. So that's kind of one of those things, if you don't know for sure what it is, we can use our calculators to get it. And so because of that, that means a times 0 is 0. And so all we have left is k is equal to a -1. Okay. And so that gives us a key point because now we can plug that in here. And now we can plug in our second point. And so then y is equal to 3 on the second point equals a, we don't know, times ln of x again is 4 this time. Oops, that's a plus, not a comma. Plus 3. And then we had -1. So we know we're shifting down 1 basically. All right. So now we have to do this. So that's going to be 3 equals a ln of 7 minus 1. Well, now we have to add 1 to both sides because now we got to simplify and solve for a. So that's 4 equals a ln of 7. Now we divide by ln of 7. And so a is equal to 4 divided by ln of 7, which we can calculate. And so it's going to be 4 divided by ln of 7. And so 2.0559. So we'll write that down. 2.0559, I think it was. All right. So what do we want to use for this? Do we really think that 2.0559 is what we should use? I mean, that's getting out pretty far when we're not even sure if it's really -2, -1, and 4, 3. And so what I suggest is, because we have 2.0, let's just round this to approximately 2. Okay. Now, some of the questions in the homework, they're going to say, okay, well, let's leave it as 4 over ln of 7, and that would be what we would put. But I'm going to say, well, let's, for simplicity's sake, let's just say that our equation now is y equals 2 ln x plus 3 minus 1. Okay. Now, again, we could put this whole thing here and put that in place of 2 instead, but I'm not sure about that number right there. I'm not sure if it's really a 4, 3, and this one looks pretty close to the -2, -1, but that one I'm unsure of, and so that's why I'm saying, okay, well, let's round here and just make it a 2, and so then that is going to be our new function, or our function rather, our equation for this graphed function here. Okay, and again, this is one of those things, sometimes they'll say, you know, put it in exact values, and the exact value would be that. Other ones, it'll just say kind of given an equation. And in that case, because, you know, everything's rounded, we're assuming a lot of stuff there as far as if those 2 points really are what they are. And I'm just saying, well, let's just round that to 2, you know, 2.0. Okay, well, even if we round that up to 2.1, that just gives us, you know, 2 if we round that. So no matter how we look at it, that's still approximately 2. And so we'll have the 2 times our ln of the x plus 3 minus 1. So the key point, that's for sure. That one, we're pretty sure on that one, it gave us an actual number. And so then that's the one that we're the most unsure about, but we're going to label that as a 2. Okay. All right. So that's all I have for today. So next week, we will work on, what is it left here? We have 4.5, we have 4.6, and I think 4.7 is our last thing. And then I've been kind of thinking, and I'm thinking maybe just because the way this whole semester's turned out, instead of a final, we'll just do a chapter 4 exam, and I'll figure out the time that we're supposed to take that on the week of finals, and that'll be what our final exam will be. Will just be chapter 4. Does that work for everybody?
That works for me.
All right.
Sounds good.
All right. So that's our plan. Next week we'll just kind of probably have 3 days of lecture, and then we can do 1 day of review, and then we'll take the final the following week, and then the semester's over. So.
Are you gonna make a study guide kind of like you did for the last exam?
Yeah, I'll get that, and we'll probably we'll go over that on next Thursday is probably what we'll do for the review.
Okay.
All right. Have a good weekend.
See ya.
Yep.
Are we still meeting tomorrow?
That's what I was just going to ask you, and I'm like, oh, hopefully she didn't leave. If you want to, we can.
I would appreciate it, yes.
Okay. And what do you think you want to cover?
Um,
The graphene, the other stuff, or?
the graphing makes actually more sense than the other stuff.
Okay, so we can work on 4.1 and 4.3 then.
Okay, sounds
Okay.
good.
All right. See ya.
Thank you. Bye.